in the reduction formula, we are gonna take, so do you know the reduction formula?
I only used it in the homework, and I just saw some pictures like I've heard about it. Like it's like there's, I just remember there's like a 1/2 involved somewhere. That's all I really remember when I used it. Like I haven't ever learned it before. I feel like I'm gonna learn it this semester, but it's a new concept.
Yeah. So this reduction formula is basically you have inside the integral, we have, again, we'll be doing the integration by parts and everything. Inside the integral, we have some power of some exponent of sine, and we will be just reducing this exponent. That's basically the reduction formula. So it's given by this. This will be equal to negative 1 over n times cosine of x times sine raised to n minus 1 x plus n minus 1 over n integral of sine n minus 2 x dx. Okay, and here this is only applicable when your n is greater than or equal to 2, and obviously it has to be an integer. It is an integer greater than or
Does that say n minus 2 over here on the sign n minus?
n minus 2, yes.
So this is only used if n the integer is greater or equal to 2?
Yes.
Okay, got it.
Okay. So whenever you have this type of integral, so how will we solve it? So the reduction formula is basically, we will continue in terms of n only. So you might feel, slightly confused, but I'll make sure you don't feel confused. Okay. So here what we have to do is, when you have sine, you have n, right? So assume that for a second, if you assume that this is sine 4x, so what we have to do is, we will factor out one factor of sine outside, and we keep sine cube x like this, and then we make the substitution of, we take this one as u. Okay, we will take this one as u. So let's just do it in this case when we have n. Okay, all right, so I'm going to write this as sine raised to n minus 1 x times sine x dx, this expression.
Okay.
Is this step clear?
Yes.
Yes, because basically if you add the exponents, so n minus 1, this one is 1, so n minus 1 plus 1 is nothing but n. So I have written n as n minus 1 plus 1. Okay.
Okay.
Now we will use integration by parts. So in this case, we are going to take this one as our u, okay, and this one as v prime. Okay, let's do this. So my u is sine n minus 1x. What will be u prime, derivative of this?
Man, the n minus 1's killing me. Okay, sine to the power n minus 1. Okay, I know the derivative of sine is cosine, but is it n minus 1 times cosine x?
Yeah, that's right, and you're missing just one thing. So let's do it simply. If you have this sine 4x, then what would be its derivative?
4 cosine.
4, and
Wait.
we will reduce
Sine.
the power of sine as well. So 4 sine cube
Sine cubed. Oh my god, cubed x
times cosine of x.
cosine x.
Exactly.
So this would be n minus 1 times sine n minus to the power of n. Wait, minus 2?
Yes.
Be reducing it? Okay. Times cosine of x.
Yes. Cosine of x dx.
Dx. Yeah. Okay, that was a mouthful.
Yeah, that's not, we don't need dx actually, because we are not writing du. Okay, so this is there, and our v prime is sine
It's
x.
sine
So what is v?
minus cosine of x.
Minus cosine of x. Okay, so now let's put everything in the formula. So u times v, so we have sine n minus 1 x. V is negative cosine x
Minus x, yeah.
minus integral of u prime is this times v. So v is negative cosine of x. So I'm taking this negative sign outside, so this becomes positive cosine of x dx. Okay. This is a really long expression, but okay. Now this one, let's rewrite this. So this is, negative cosine of x sine of n minus 1 x plus n minus 1 sine n minus 2x. Cosine x times cosine x, that is nothing.
Squared x.
Cosine square x dx. Okay. Now we know that what is cosine of square x?
We have 3 options, but technically speaking, wait, no, cosine squared x? Oh, 1 minus sine squared x. What am I saying?
1 minus sine square x, exactly. So we are going to do that.
Just replace it.
Yeah, I'll not write the entire thing. Okay, so this is
1 minus sine squared x.
1 minus sine square x. And I will now copy this entire thing. So this is 1 minus sine square x. Okay, and now if you see this n minus 1 is actually a constant, because n is going to be an integer. So this is a constant, so I will take it outside of the integral in the next step. Then again I'll copy this entire thing. So I'm writing this as n minus 1, I'm bringing it outside, and inside we are left with this. Okay, and now we will distribute. Now I'm going to distribute this inside. All right, I hope you're following this, right?
Yeah.
Okay, so this becomes integral of, I'm just distributing this thing, this guy. First I'll multiply it with the 1 and then I'll multiply it with the negative sine square x. Okay, so this becomes integral of sine n minus 2 x dx minus integral of sine n minus 2x times sine square x.
Could you give me 1 second to copy this down?
Yeah, sure.
This is a huge problem.
I know.
Okay, got it.
And now we just have to do some algebraic manipulation here and there. So this becomes... You've written this, right? Okay.
Yeah.
Don't remember where we started from. We started from this expression, okay? Sine raised to nx. And you'll see life revolves in full circle, and now we will actually land up to this expression again. So I'm just writing this on the left hand side. This is sine nx. This is what we are trying to solve. And now let's simplify. So let's try to simplify this expression, Arushi. This one. Can you tell me what will be the value of this?
Wait. Why does this look so familiar? To simplify the least, isn't it just... Wait, sine to the 0? Because what happens is if you do sine n minus 2 plus 2, it's just sine to the n.
Yes, exactly. This will be just sine to the power n, because you add the powers when the bases are same and you're multiplying the powers, right? You add the exponents. Right. Exactly. So this is nothing but sine nx. That's it. Okay, so now we will write this entire thing. Okay, and you can see that we are very close to our solution. Sine n minus 1x plus, and now okay, let's do it. N minus 1 times, I'm distributing this n minus 1 inside now, so this is integral of sine n minus 2x dx minus n minus 1 integral of sine nx dx. Are we good so far?
Yes.
Okay. And if we go back and look at our reduction formula, it says this, n minus 1 over n. So when you have n minus 2, this is multiplied by n minus 1 over n. So we already have this n minus 1. Wait a second. Yeah, we already have this n minus 1. Yeah, now I'm going to distribute this n minus 1 inside. Just bear with me for 2 minutes. It's very near to the completion. Now I'm going to distribute this guy. Okay? Not this guy, actually we are distributing this integral. You multiply this first with n and then with negative 1. So let's just do it on the other side over here. So we have negative n minus 1 and this is multiplied by sine of this integral. So firstly, this is nothing but negative n plus 1. First I'm distributing this.
Sine of n to the x.
Yes.
And wouldn't the integral of sine n to the x just basically be cosine of n to the x?
No. If it were that simple, then why we were doing this.
Oh, never mind. My bad. Okay.
Yeah.
Never
So you
mind.
see that we are getting the same expression that we started from. So now I'll distribute this. So this becomes negative n integral of sine nx dx plus integral of
Sine n to the x.
dx. Yes. Okay. So this is the final expression. So I'll write this. I'll just copy this entire thing again. And then I'm getting negative n sine nx dx. What was the next term? Plus
Sine n plus integral sine n to the x dx.
yes. Now what do we have on the left hand side? On the left hand side we have this thing.
Mm-hmm.
Yeah. Okay. So this guy and this guy will cancel out. If you subtract this exact term on both the sides, we can cancel this out. Sine nx, sine nx. Okay.
Yeah.
Yeah.
Right.
Right. And then we are left with this guy. And all the other terms I will bring on the left hand side. So this term I am bringing on the left hand side. So this becomes positive cosine of x sine n minus 1x. This term also I am bringing on the left hand side. So it becomes negative n minus 1 integral of sine n minus 2x dx. And on the right hand side we are just left with negative n sine nx dx. And then to find out the value, I just need to get rid of this negative n. So divide the entire equation by negative n. So finally you get negative 1 over n cosine of x sine n minus 1x plus n minus 1 over n. This negative changes into positive because we are dividing the entire equation by negative n. Sine of n minus 2x dx equals integral of sine x dx. Wait.
Wow.
Let's see if we have got the thing that we wrote at the first place. Yeah, negative 1 over n cosine of x sine n minus 1x plus n minus 1 over n. So this is our reduction formula. This is basically the proof of reduction formula.
I see. Huh.
This can be asked in your exam because this is a subjective thing. They will straight away give you the question, prove the reduction formula, and they will give you this formula and you will have to prove it.